Hey guys, it's Tanya from Trio, and I am recording a new video today for you. Chapter 3. It's going to be over matter and energy. And there's a lot of information that we have to get through in this video, so I won't spend too much time on definitions or key terms. But I did write down a few key terms that I would like for you to pay special attention to, because we'll be using these often during this chapter and throughout this video. So, matter. Matter, the definition is anything that occupies space and has a mass. So, for example, this bottle of Expo Wipes is matter. Because it takes up space and it has a mass. So a mass is weight. Molecules. So molecules are two or more atoms joined together in a specific geometric arrangement. And we won't go over too much of geometric arrangements, but just think of atoms as water. So H2O. These are two atoms joined together to make a specific arrangement. So if we were looking at this molecule in the lab, it would look like this, right? Well, not exactly like this. It would be more like this, okay? But this is a molecule. And a heterogeneous mixture. I always have trouble with that one. So a heterogeneous mixture is a mixture like oil and water that has two or more regions with different compositions. So think about your favorite oil and vinegar salad dressing. When you pull it out of the refrigerator, it's visibly separated with your oil on the top and your vinegar and all your spices at the bottom. But when you shake it up, it blends together, right? That would be a heterogeneous mixture. A homogeneous mixture would be my cup of coffee with my cream and sugar in it. Each apart, these three substances each have a different composition. But when I mix them together, the molecules combine and it makes a smooth, consistent substance. So that would be a homogeneous mixture. So it actually has the same composition throughout. So those are just some of the definitions that I wanted to talk to you about before we get too deep into the video. We're going to talk about properties today. So properties are characteristics that distinguish one substance from another. So for those of you who have siblings, so your characteristics are different from those of your brother or your sister. So that's what a characteristic is. That's what a property is. It's a characteristic that distinguishes one substance from another. Okay, and a physical property is one that changes a substance without changing its composition. Okay, so that would be color, taste, appearance, melting point, boiling point, and density. A chemical property. So a chemical property, this is where we get into what's actually relevant with what we're doing here today. A chemical property is one that a substance displays only through changing its composition. So that would be like flammability, corrosiveness, acidity, toxicity. So those are some of the chemical properties, the physical characteristics of chemical properties. So the law, there is a law of constant composition, and it states physical and chemical changes do not destroy matter, nor do they create new matter. Okay, so that's just some important terminology that we needed to discuss before we get, like I said, too deep into chapter 3. It's all relevant information, and as you look over your professor's notes, the PowerPoints, or read through the chapter and start working some of the problems, you'll understand why. You may be asked to do some practice problems where she asks you to identify either a physical property or a chemical property. We're not going to take the time to work any of those practice problems. They're pretty easy. And if you look in your textbook has different examples, and it'll show you the differences between the chemical properties and the physical properties. Okay, so just briefly, the conservation of mass states, the law of conservation of mass states matter is neither created nor destroyed in a chemical reaction. Keeping this in mind, you may be faced with some problems where you are given a certain number of grams of one substance and a certain number of grams of another substance and asked to find the total mass of that substance. So I'm just going to show you a couple of quick examples in case you see them on a quiz or an exam. These are also in your textbook. One thing that got me through Intro Chem when I was taking the class was working the skill builder problems and reading over the example problems. The example problems your professor uses when she's lecturing, or he or she is lecturing. So pay careful attention to them, because a lot of times you'll see those sample problems or example problems again on an exam. That's almost a guarantee, guys. So just keep it in mind so your professors don't point out these worked problems for a reason, for no reason. They do it because they reuse that material and include it in their exams. So pay careful attention if your professor gets up while she's lecturing or he is lecturing and works a problem on the board, because you're going to see that problem again. Okay, so we have 12 grams of natural gas, and it combines with 48 grams of oxygen. Okay, and so to determine the mass of these two substances, all we would do is take 12 grams, add it to our 48 grams, and get 60 grams. So real simple, just adding. Probably the easiest thing we're going to do in chemistry. But I just wanted to show you this example. So this chemical change actually produces carbon dioxide. So we need to determine how much carbon dioxide is produced from the combination of natural gas and oxygen. And we can do that by taking our 60 grams, which is our total mass. So this is our 60 grams. And we're told in our problem that we produce 33 grams of carbon dioxide. Okay? So we're being asked to determine how many grams of water are formed. So it's just simple subtraction, guys. 27 grams of H2O. All right, so moving on. So energy. Energy is a big topic for this chapter. So let's go ahead and take a look and see what energy is. We all know that some days there's just not enough energy in the world to get you out of bed because you're just so exhausted. Energy is defined as the capacity to do work. And work is defined as the result of a force acting on a distance. The law of conservation of energy, and you do need to know this, states that energy is neither created nor destroyed. So it's just like the law of the conservation of mass. Mass is neither created nor destroyed in a chemical reaction. Energy is neither created nor destroyed. Okay? The different types of energy that you need to be able to identify are kinetic energy, which is energy associated with motion. So when you're moving, that's kinetic energy. Potential energy. So potential energy is energy that is associated with its position or composition. Then we have electrical energy, and that's the energy associated with the flow of an electrical charge. So when you plug in that cell phone, it's using electric energy. You guys see the electric bills, I'm sure, every month, so that's electric energy. It's enough to make you cry sometimes. Thermal energy. So thermal energy is another type of energy that we need to know, and that's the energy that's associated with the random motion of atoms and molecules in matter. So the hotter an object, the more thermal energy it contains. So this coffee, when it's hot, contains a lot of thermal energy. If I were drinking an ice water, the ice water would contain thermal energy, but not as much as the hot coffee. Okay, so the next type of energy that we're going to talk about is chemical energy. And chemical energy is a form of potential energy that's associated with the positions of the particles that compose the chemical system. And so this is not really anything that you need to spend a lot of time studying or working on. These are just some types of energy that I wanted to point out to you as we move further into the material in this chapter. So we're going to be talking about conversions. So last chapter, chapter 2, we did a lot of unit conversions. And we are going to, in this chapter, we're going to be doing even more unit conversions. We're going to be using the SI unit of energy is the joule, okay, Joule. And it is the measurement of energy, as I just stated. And so we're going to be converting from calories, kilowatt hours, to joules, which is the standard unit in science for energy. So we're going to talk about that next. Okay, so we talked about energy, the different types of energy. So the SI unit for energy is the joule, Joule, and the abbreviation for that is a capital J. So if you look, if you're using the textbook, page 73 has a little table with the energy conversion units, but I put them on the board here. If you want to jot these down on a flashcard, you need to memorize these. So 1 calorie, and this is with the little c, is equivalent to 4.184 joules. And then we have another type of calorie, as though calories, we didn't have enough. 1 calorie with a big C is equivalent to 1,000 calories with a little c. I know it's very confusing, but this is a little c, and this is a big C. Okay, and then a kilowatt hour is equivalent to 3.6 times 10 to the 6th joules. So these are units that you need to memorize. So you might want to pause the video now and jot these down on a flashcard, and then when we come back together, we're going to work through some conversion problems, some energy conversion problems. Okay, so we are going to convert 225 calories to joules, right? And this is big cal. This is with the big C and not the little c. So we need to take a look and see, based on what you learned last chapter, chapter 2, in our unit conversions, I use a solution map. So if I were going to draw my solution map, I would take it from big calories to little calories and then to joules, right? And so I've put our relationships here in the upper right hand corner for you. So our conversion factor here is for every 1 calorie equals 1,000 of the little c calories, right? And so for every 1 of the little c calories equals 4.184 joules, okay? So just like we did in the last chapter, we're going to plug in our information that we're wanting to convert, and we're going to work through this problem. So we're going to convert 225 of the big calories. We'll multiply across, and our answer is going to be in joules, right? So these units are like units, so they're going to cancel out. We have these like units that will cancel out. When we multiply across, the answer that you should get is rather large, 941,400. And putting this in scientific notation, which is what your professors are looking for, it would be 9.41 times 10 to the 5th joules. Okay, So you will be doing several problems like this, both on quizzes and exams. So like I said previously, get that flashcard, write those units down, and work on memorizing them. If your professor gives you homework, make sure you take the time to do that homework because that homework is good practice. The repetition will help you understand the concept and develop the skills. So the big thing with Intro Chem, you do a lot of unit conversions, and you've got to learn how to do this early in the semester in order to be successful throughout the semester. So my tutorial videos don't include a lot of practice problems, but there are problems in your textbook, and then your professor posts homework pages. So do those homework pages. Even if you've only got 5 or 10 minutes to work on them, every little bit helps, okay? So the next thing that we're going to look at is temperature, okay? Okay, so 2 specific types of energy that we need to pay particular attention to for this chapter, chapter 3, is exothermic energy and endothermic energy. So exothermic energy is energy that is released. Endothermic energy is energy that is absorbed. So when you're thinking of exothermic energy, think of that match that you light. When you light a match, it gives off heat. So it is actually releasing energy, okay? An endothermic energy, an endothermic reaction is, think of those chemically activated ice packs, okay? When you break that center core, it immediately gets cold. So it is absorbing energy to make it cold. So that would be an endothermic reaction. In terms of chemical reactions, we have our energy here. These are our reactants and our products, right? So when we have an endothermic reaction, an endothermic chemical reaction, energy is absorbed into the products. When we have an exothermic energy chemical reaction, energy is released, right? So that's just a little definition there. It'll make more sense as we begin putting all of these pieces together and start talking more about specific heat. But before we do our temperature conversions, I wanted to talk to you about these 2 specific types of energy, because these are types of energy that you will see again this semester for Intro Chem. So it's good to have a valid or a good understanding now as you move forward, okay? So let's take a look at temperature conversions. Okay, so the standard unit of temperature in science is the Kelvin, right? And the conversion factor for kelvins, or the equation, equals 273.15 plus degrees Celsius. So you can convert from Celsius to kelvins fairly easily, okay? In order to convert from Celsius to Fahrenheit, it's a little bit different. So for Celsius to Fahrenheit, or Fahrenheit to Celsius, however you want to look at it, we use this equation. Degrees Fahrenheit minus 32 divided by 1.8. So in some of your math classes, you might have seen this a little bit differently. You might have seen it as 9/5 times Fahrenheit minus 32, or you might have seen it as 5/9. So just depending on what unit of temperature you were trying to convert to, okay? So these are the 2 standard equations that we use for converting from Celsius to kelvins and Fahrenheit to Celsius. So with these 2 equations, we can pretty much convert any temperature, okay? So let's just work a couple of examples. We want to convert, and we'll do a few of these, 212 kelvins to Celsius, right? And being from the United States, we don't use a lot of temperatures in Celsius. And kelvins are primarily used in the lab. We mostly deal with Fahrenheit. So this is good information to know. So we take our 212 kelvins, we want to convert them to Celsius, okay? So what we're going to do is, let me just grab my calculator. So our kelvins equals degrees Celsius plus 273.15. So now we're going to use our algebraic knowledge, and we're just going to swap these. So we're looking for Celsius. So we're going to take our kelvins, 212 minus 273.15. Okay? And that's going to give us negative 61 degrees Celsius. Okay? So we just flip-flopped our values here. Okay? Let's work through another one. Okay, so let's look at converting negative 25 degrees Celsius to kelvins, okay? Based on this formula, these formulas here, we're going to take our standard formula, kelvins equals degrees Celsius plus 273.15. So we're going to plug in our values, our negative 25 degrees Celsius plus 273.15. So kelvins is going to equal 248.15. Now your professor here is not real picky when it comes to rounding. So we'll just round it and leave it a whole number. So our answer is 248 kelvins, right here. So these are not hard. We'll do some more. All right, so we're going to convert negative 321 degrees Fahrenheit to kelvins, okay? So what we want to do here is our solution map. So we need to go from, we can't go directly from Fahrenheit to kelvins. So we have to go from Fahrenheit to Celsius and then to kelvins, okay? So knowing that, we're going to use our formula for Celsius. So we're going to find our degrees Celsius first. So we have our degrees Fahrenheit, which is negative 321 degrees Fahrenheit. We're going to subtract 32, and we're going to divide by 1.8. So when you put this into your calculator, we have negative 321 minus 32 divided by 1.8. So that should give you a value of negative 196 degrees Celsius. So now in order to find kelvins, we're going to take this value negative 196 degrees Celsius. We're going to add 273.15, and that's going to give us $77.15. Again, with the rounding, 77 kelvins. So that's probably one of the more difficult ones that you'll see when you're working your homework problems. Like I said, these are not difficult as long as you have a good understanding of unit conversions, okay? So the more fun, the meat and bones part of this video is really specific heat. So we're going to go ahead and take a look at specific heat. So now it's time for the fun stuff. Okay, so specific heat. Specific heat capacity, or shorter version would be specific heat. The specific heat capacity of a substance is the quantity of heat, usually in joules, since that's our standard unit of temperature for science, is the quantity, the amount of heat that is required to change the temperature of 1 gram of any substance by 1 degree, okay? The specific heat capacity has units of joules per gram per degree Celsius, right? So that's a lot. So it would just look like this in your answer, joules per gram per degree Celsius. That's what your answer would look like, okay? And so the formula for specific heat is Q equals MC delta T. Q is the amount of heat in joules. M is the mass of your substance in grams. C is your specific heat capacity. And delta T is your change in temperature, okay? And so we're going to take everything that we've learned up to this point and apply it to this equation here to solve and find specific heat, okay? And we're going to do several of these problems because they will be on your first exam. They're going to be on your next quiz. And there is going to be probably a workshop. Professor LaPaula tries to do a workshop over specific heat just so that everybody has a good foundation and understanding of how to work these specific heat problems, okay? So if you get a chance, she usually does it over 2 days. She'll do like a Tuesday and a Wednesday, and they're usually just an hour, so it's just an hour of your life to learn something good, okay? And so given this information, we're going to work through a few specific heat problems, and then we'll move on to our next topic, okay? Okay, so I'm going to read this problem to you, and then I'm going to show you how I came up with this information. So one thing that I always struggled with when I was in secondary school or junior high and high school was story problems. And so when you're reading a story problem, you really need to pick it apart in order to make sure that you have all of the pieces that you need in order to solve the equation, right? So this problem says gallium is a solid metal at room temperature, but melts at 29.9 degrees Celsius, okay? So if you hold gallium in your hand, it melts from your body heat. How much heat must 2.5 grams of gallium absorb from your hand to raise the temperature of the gallium from 25 degrees Celsius to 29.9 degrees Celsius? The specific heat capacity of gallium is 0.372 joules per gram degrees Celsius, okay? So what we've been given is, based on our equation, our mass is 2.5 grams of gallium. So this is our mass. And our initial temperature is 25 degrees. We're trying to find what it takes to raise the gallium from 25 degrees Celsius to 29.9 degrees Celsius. So this is our delta T, right? This is our temperature change, okay? And then our C, which is part of our equation as well, is the specific heat capacity of this element, okay? So our specific heat capacity of gallium is 0.372 joules per gram degrees Celsius. Now, so based on the given information, we can solve this equation and find Q, okay? So all we're going to do is we're going to take these values and replace our variables to find the value of Q, okay? So with our given information, so we have Q equals 2.5 grams times 0.372 joules per gram degrees Celsius. And then our change in temperature, so what I did not show you on our delta T, so our delta T is our temperature, our final temperature, subtract our initial temperature to get our change in temperature. So in this case, our final temperature was 29.9 degrees. Our initial temperature was 25 degrees. So we're just going to subtract those. And so our delta T becomes 4.9, okay? And so that's our last value that we have to plug in right here. 4.9 degrees Celsius, okay? So when we multiply these across, you should come up with 4.557 joules. And if we were to round this up based on our scientific notation, this would be 4.6 joules. Okay, so let's go ahead and let's work through another problem. Okay, so breaking down the sample problem, we have our given information. We have a mass of 14.3 grams. Then we have our Q equals 174 joules. And then we have our initial temperature, which is 25 degrees Celsius, and our final temperature, which is 52 degrees Celsius. So based on these two temperatures, we can find our change in temperature, which is 27 degrees Celsius. So for this particular equation, we're no longer solving for Q, okay? We are solving for C. So based on what we know from algebra, we have to isolate this variable, and we're going to do that by multiplying both sides, or dividing both sides by mass and delta T. So C is going to be equal to Q divided by M delta T. So when we plug in our values, Q is our 174 joules. M is our mass, 14.3 grams. And then our delta T is 27 degrees Celsius. Okay, so we're going to multiply these two values, and then we're going to take that product and divide it into the 174 joules. And then the answer that we're going to get is equal to 0.4507. If we round that up, we're going to get 0.45 joules per gram degrees Celsius. And if you guys are wondering where I'm getting these sample problems, they're actually from the textbook. These are the example problems in the textbook. You can follow along if you have a textbook. If not, then I will provide the information for you. So at the end of each problem, there'll be a skill builder. And these skill builders are really good practice. And then underneath the skill builders, it'll tell you for more practice, and it gives you several problems. And so the problems that it refers to are going to be very similar to the sample problem that you just worked. So if you're looking for some more practice, this is definitely a good source of practice for these homework problems. Okay, so that is specific heat. I know that we have covered a lot of information, but I wanted to make sure that we hit all of the important information that's going to be included in your next quiz, and will also be on your first intro chem exam. So I'm going to go ahead, and if you want to pause the video or stop the video, I'll put a couple of example problems on the board here that you can work on your own when we come back together. Guys, based on all of the concepts that I have presented to you in this video, I've put 3 problems on the board, practice problems. The first one is convert 45.6 joules to calories, and these are the small calories. Convert 45 degrees Celsius to kelvins, and then our specific heat question, it takes 132.8 joules of energy to heat 11.2 grams of aluminum from 15.73 degrees Celsius to 28.94 degrees Celsius. What is the specific heat of aluminum? Okay, so I'm going to leave you with these 3 problems, and based on all of the concepts that I've presented in this video, you guys will be able to work through these successfully and get the answers. These probably look familiar because they're part of your homework problems, so I'm not going to work them out or put them on the board because you have to do them anyway. So this is what I'm going to leave you with. Our next video is going to be over chapter 4, which is getting into atoms and elements. So it's going to be a lot of fun. I love working with the periodic table. I like doing the chemical formulas. It's just a lot of fun for me. So I hope that you will enjoy it as well, and I'll try to make it as fun as possible. But that's going to be it for this video today. We'll have this up and posted for you, so you'll be able to review it. We'll have more videos posted over the next few days that you'll be able to look at over the weekend. But you know, it's only as hard as you make it. This is only as hard as you make it. And if there's something that you don't understand, please reach out and let me know. I'm available in Trio for tutoring. If you need to email me or call me, you can reach me in the Trio office. The Trio office telephone number is 733-7379. If you need to email me, my email address is tmitchell@rose.edu. And you can find everything that you need to know about Trio from our Linktree page. And the link is link.ee/RSC Trio. So if you need to schedule a tutoring appointment, this is the best place to do it because this takes you to our online tutor form. You can complete it, submit it, and we'll get you set up within 24 hours for tutoring. So here's our information. So reach out if you have any questions or you need some additional one-on-one tutoring time to go over these concepts. Have a great day. Take care of yourself, and see you next time.